Okay, thank you, Jeff. And I will jump right in to give you a general update of what's new on the New Horizons project. If you were on my earlier attempt where we had some tech problems yesterday, I'm using the same exact slides. About the first half of the presentation is what I got through, but we're going to do it all the way through. So second slide, please. Okay, so quick overview of where we are. The spacecraft is healthy. The payload on board, all 7 scientific instruments are healthy. Spacecraft has been in flight more than 14 and a half years. In January, it will be 15 years. Spacecraft resources, we have power from the RTG to run the spacecraft late into the next decade. We have fuel to operate for the same amount of time. We're not using any of the backup systems because there are problems. Sometimes we load share between prime and backup, but everything's working really well. And the spacecraft is in essentially as good a shape as it was the day that it launched. And if you look at the power curves, we ought to be able to operate out to somewhere near 100 astronomical units. We are currently at 48 AU from the sun. We have enough fuel on board to do another KBO flyby if we can find a KBO that's within reach of the available discretionary fuel, that is the total minus maintenance fuel minus the amount required for a flyby itself. And we are conducting searches for KBOs, which I'll speak to a couple times during this talk, so you'll learn more about it. As far as COVID, this project is particularly resilient to everyone working from home. With the exception of flight controllers that do have to go into our Mission Operations Control Center. But we've now been working essentially 100% remotely for 6 months now, since early March. And while we made some process improvements, really we're quite resilient to COVID and could work this way indefinitely. Very important part of New Horizons that's going on right now is some flight software enhancements, both on the spacecraft command and data handling system and on several of the scientific instruments. Those flight software enhancements will increase our ability to do science farther and farther from the sun, particularly with the challenge of lower and lower data rates. So one example is that we're going to be able to co-add images on board to increase signal to noise, so that we don't have to send back every image and do that process on the ground. We're also going to be enhancing scientific capabilities on board the ultraviolet spectrometer and the plasma instruments. All of that software is expected to be up on the spacecraft next year in advance of our proposal to senior review in 22. Regarding those searches for new Kuiper Belt objects, let me just say that there are 2 ways that we can study Kuiper Belt objects from New Horizons. One, operate the spacecraft as an observatory in situ in the Kuiper Belt at much closer range to individual KBOs than and because of that closer range, typically a factor of 100 to 1,000 times closer than the Earth is, we're able to develop higher signal to noise, but we're also able to see objects from different geometries and at higher spatial resolution.
Hold on, Alan.
Angular resolution.
Please mute, especially dogs who are on the line. Please mute.
Thank you, Jeff. So we can see objects from different geometries and at much closer range to higher resolution. And that allows us to do truly unique science as an observatory in the Kuiper Belt. We have so far observed approximately 20 Kuiper Belt objects in addition to Arrokoth that we made a close flyby of. So the second way that we can study Kuiper Belt objects, of course, is to make close flybys like we did for Arrokoth. And we are currently conducting a search for new KBOs to study both as an observatory and to look for flyby targets. The best tool in the world for this purpose is the Japanese SwRI Observatory, one of the largest telescopes in the world with a very fast and very wide field imager with well north of 100 CCDs in the focal plane. This 10-meter class telescope has been used by our team in collaboration with the SwRI team in May and June and August of this summer to search for those new KBOs that I just spoke about. And in fact, we have identified about 100 new KBOs, about 24 of which we expect to be able to study from the spacecraft. And we are looking for any that are within our fuel reach, but we don't have good enough orbits to really give you a definitive answer on that yet. We also plan to conduct a similar search next summer. So this will be a developing story over the next 18 months or 2 years. Next slide. Okay, I want to make a point of announcing to the OPEG community some very good news that we received from NASA headquarters earlier this summer, and that is that my request to promote several of the more junior team members to co-investigator status was approved. And here you can see the faces and names of those 5 individuals: Sue Benecki, Ross Beyer, Carly Howitt, Orkan Umerhan, and Simon White. If I can go on, I want to talk to you about PDS, give you a good update on what we're doing there. We've been making twice a year deliveries to the PDS so that you have access and all of the community has access to the data that's coming down from New Horizons. This June, we made the final delivery of Arrokoth pixels. Now, all the pixels from every instrument and every data take on Arrokoth are on the ground, with the exception of a few images made at fairly far range that we still haven't brought to the ground because they're lower priority. But all the high resolution data is now in the PDS. And we also updated our crew science deliveries and are keeping up with that. Next month, in October, we'll make another PDS delivery that will have more crew science data. It will also contain the results of a very comprehensive calibration campaign that we performed last year on the instruments that have caused some of the calibration parameters and keywords in our pipelines to be updated. And so we have rerun the data sets and recalibrated them that were already submitted to now account for those calibrations. And we've begun to send to the ground the so-called Arrokoth sky pixels. That is the black sky pixels around the target itself that are best used for searches for satellites or orbiting debris, dust structures, things like that. They're coming home on an as available bandwidth basis, and they'll continue to come home, these sky pixels, for a couple of years as we keep up with the other types of data that we're sending to the ground. Next year, in addition to doing all of those things, we are also going to be submitting the first meta products from the Arrokoth flyby, essentially maps, and some new meta products from the Pluto flyby. And those will be submitted next August and then peer reviewed and then released to the community in the latter part of 21. Next slide. As I mentioned yesterday, this summer, actually this spring and summer, we undertook a public engagement project that's worth noting. Many of you are teaching classes. Our spacecraft is now far enough from the sun to be able to see the very nearest stars shifted in position relative to how they appear against background stars as seen from the Earth. So in April, we undertook a campaign to image 2 very nearby stars, Proxima Centauri and Wolf 359, simultaneously from the Earth and from the spacecraft in the Kuiper Belt. And then we put those products together to actually make a visceral demonstration of parallax and how the position is of those nearby stars is different. And we think that this not only made a very nice press release, the first time that interstellar navigation had been done, we used this parallax to actually reconstruct without any deep space network tracking the position of New Horizons in the Kuiper Belt, essentially to navigate by the stars from this very great distance. But all those textbooks that talk about parallax, the 101 astronomy type textbooks, have always had to use cartoon figures because the actual parallax shift that one sees across the Earth to a U baseline is so small that it's very hard to just see it with your naked eye. But these images from New Horizons allow anyone to see that shift in position. And so in addition to being a great public engagement project, We think that this is going to impact all the astronomy textbooks over the next few years as their new editions come out, because now every unit with a 101 on parallax can now, for the first time, show a product like this and really make clear what's going on when we talk about parallax and how we measure the distances to stars. Next slide. In the science category, there's also a lot going on. We have a special issue of Icarus, which is now essentially in the can, 25 papers that have been accepted and which will be published together as a group in the January 2021 issue of Icarus. They span all of these topics and more. There are quite a number of new results on cryovolcanism of various styles across the surface of Pluto and Charon. New evidence that Pluto is an ocean world in several regards, and the astrobiological potential of that is high enough that when we submitted a paper to Astrobiology last year on this very topic, the journal decided to put Pluto on the cover to emphasize these new results. We've also undertaken projects to look at the imagery made by New Horizons of Pluto's far side and Charon's far side, which, although lower in resolution than the near approach hemisphere, are still very much more detailed than what we can do from the Earth or the Hubble, or have any prospect of doing from the Earth or future space observatories in the coming decade or two. Those results have also now been written up. The Pluto Farside paper is one that I led, the Farside paper. They both contain a variety of new results about the geology of those far sides, which I don't have time to go into, but which have some surprising findings. There are also papers on the sublimation pits that are across the Sputnik-Planitia Glacier, the chaotic mountain blocks on the margin of Sputnik Impact Basin, on the geophysical implications of crater relaxation observed on Pluto, particularly for large craters that let us probe into the properties, the rheology of Pluto's crust, and various other topics. So there are a lot of new results coming out. Most of these are now available on the archive or even electronically at Icarus. There are also a wide variety of papers coming out in other journals. And I'll now go to the next slide. And I just want to make an illustration of one particular result.
Alan, we have a minute, by the way.
Okay. And that is a result by Dale Cruikshank about cryovolcanism that has flooded a portion of Pluto called Viking Terra with a water ammonia slurry that also contains organics, and which probably provide clues to what's going on in the interior ocean, which sourced this flooding. Next slide. Very briefly, I'm just going to hit on a couple of closing topics, Jeff.
Okay,
next slide, please. Yep, the Space Science Series book called The Pluto System After New Horizons is now complete and in the final stages of page editing. It will also be out in January of next year, and you just briefly saw the cover for it. It's already available to be ordered as soon as it's actually produced in paper and available for shipping. This year, we've been concentrating on new results from the flyby of KBO Airkoth. The Spencer et al., Grundy et al., and McKinnon et al. Papers came out as a triad in the journal Science earlier this year, and we were asked to give a press conference at the AAAS meeting just before COVID prevented further travel. If I can have the next slide, I just want to say that the result that I'm proudest of, and you may have your own favorite, but the result that I'm proudest of are our results concerning the formation of Airkoth and the strong evidence for gentle accretion and subsequent tidal evolution, which was detailed in Bill McKinnon's paper in Science in this triad, and which so strongly points to the streaming instability and pebble accretion as the formation mode for planetesimals, at least in the outer solar system. I believe that's the last slide.
Okay, thank you, Alan. I know you have to take off. So although there is a walk-on presentation from Kurt Niebuhr. Let's take one or two quick questions for Alan, then we'll go to Kurt, then we'll go into our general question and answer session. So, Abby, do we have a question or two for Alan?
I do. Thanks. From Alison Murray at DRI. This is on the planetary protection topic. Did the review also consider that in addition to ocean worlds not being equal, that not all missions to these ocean worlds are equal or pose the same risk? Second question, could you provide examples of what different criteria might be utilized? How might criteria be different for missions to Titan, Enceladus, or Europa?
Yeah, let me take those in turn. They're both very good questions. The answer to the first question is yes. There were several axes that we pointed to, not just the difference in the details of what we know about the individual ocean worlds, but also, as was asked, there are differences in mission style. And what we recommended was essentially that on a case-by-case basis, pairing target and mission type, that NASA take a look and tailor the requirements and the implementation unique to each mission, rather than treating all the ocean worlds and all the missions to them as if they were all identical. Would you repeat again, Abby, the second question so I get the answer, hitting the nail on the head?
Sure. Could you provide examples of what different criteria might be utilized / how might criteria be different for missions to, for example, Titan, Enceladus, and Europa?
Yeah, let me though give that answer a little bit different way. Instead of by different target, by different mission type, which relates to the last question.
Mm-hmm.
So if we put an orbiter in the Saturn system to study Enceladus, then we should expect to have very different requirements on planetary protection and controls than we would if we wanted to go down to the surface and actually put a lander down near a plume site or a plume fallout site, as an example.
And an excellent final point from also from Alison Murray on the pragmatic adoption of it. How will the committee's finding that less than a cell requirement for planetary protection be adopted?
Well, I'm not a biologist, so I'm not expert in the details of how one goes about making tests like that. So I can't really answer that question, but I'd be happy, if desired, to go and get the answer and then come back and we'll deliver it to OPEC.